So in the same two triangles, you have a smaller one with a height of A, a larger one with a height of B, making sure that A and B are the corresponding sides. Their scale factor is A to B, but the ratio of their areas is A squared to B squared. Okay? My new arrangement makes y'all look so far away. It's like empty right here. My table's not there anymore. I like it though.
You like it?
I do.
But now your table's up by your.
That's alright. Because when y'all file papers, I was all in the way anyway.
You heard that, people?
Okay. What is that?
Texas.
Texas.
See that? They made fun of my picture of Texas. It looks like Texas.
That does look like it.
That is
Not like your husband's Texas. Your husband would make like every
Yeah,
little.
it would be perfect. He'd have like every little stream and river and the major highways and whatever. Okay. All right. As you're going to see, as long as we can compare two corresponding parts, right? And what I have here is that the distance from the outer edges, the farthermost outer edges of this image is 8 units long. And the same image blown up, that same distance from the outermost edges, is 12 units long. So even though we don't have a specific height and a specific radius and a specific all this other crazy stuff, as long as we can compare those two things, we know the scale factor. So it's 8 to 12, which reduces to 2 to 3.
And there's a small one have to go first.
It doesn't matter. We're going to put the small one first. Just because that's what we're going to do. All right? Okay. Now, that means that the ratio of their perimeters is what?
2 to 3.
2 to 3. Yet the ratio of their areas is 4 to 9. Okay. Now, today we're just going to work on figuring, which is so simple. So super simple. But the way we can use this information is like this. Okay? Now I'm making it up as I go, so be patient. You want to buy a cattle farm. And so you're going to buy acreage. And you go to this old man who used to own 100 acres of land, and he's splitting up his land into plots. All right? Huh?
Ted Boudreaux.
No. Old MacDonald. He had a farm. Okay?
Yeah.
All right. And he has a picture because you're not going to go walk 100 acres. You know how long that would take you. All right? But you want to get an idea of exactly how much you are purchasing. And his map is to scale for his 100 acres. Okay? Where he might say 1 inch represents 1 acre. All right? And so what you can do is say, all right, if the map, what did I say, 1 inch represents 1 acre? Well, let's do it better. Let's say 1 inch represents 10 acres. Okay, if 1 inch on the map represents 10 acres on the actual land, what's the scale factor? 1 to 10. All right? Okay, suppose on the map, you are purchasing, or excuse me, on the map, the little plot that you're going to get is 2.5 inches by 5 inches. And you want to figure out exactly how many acres that is. All right, well, what you're going to do, what you can do here is you can find, first off, what's the area of this? That's not what I want to do. See, I told you, I'm making it up as I go. Hold on. So you have a little piece of paper. And yeah. So, you can't say 1 inch represents 10 acres. Why? Because 1 inch is a straight line and an acre is an actual area.
1 square.
Duh, that's why it's not working. Okay. One square inch represents 10 square acres.
So 1 by 1 by 1 by 1.
1 by 1 by 1.
No.
So on the map, you're getting
That's really bad version.
9 square inches. How many acres are you actually purchasing? 90 square acres. So without even knowing the actual dimensions of the land, like saying it's, 9 whatever this way and 10 whatever this way, and so it's 90 square feet or 90 square acres or whatever, we can figure just by using this scale how much we're going to get by just looking at the picture. All right? Hey.
Hey, baby.
Well, that was fun.
Bye.
No homework tonight. We're going to pick up from here tomorrow, and homework is tomorrow night.
Thank you.